Welcome to Module P3 Part 1, where we're going to be doing some solving systems of equations using substitution. And this is Team Glaze. And after this lesson, I want you to be able to use substitution to solve a system of two equations with two unknown variables. Now to build onto this, let's just back up a little bit and take a look at some work you did a couple years ago. In the 8th grade, we did some solving of equations graphically, and there were three scenarios there. One of them was when you had no solution, and that happened when you had two parallel lines. And then you had one solution, and that occurred when the lines crossed in exactly one spot. Or there were infinite solutions, and that occurred when your lines were overlapping, so they were the exact same line. Now with that in mind, let's take a look at some specific examples of how to solve, and we'll go through the methods of solving systems using substitution. So here's the first example. Y equals 3x plus 6 and y equals negative 3x. Now, let's go back to the definition of substitution. Substitution says we're going to substitute one thing for something else. Now in this case, I'm going to take my top equation and I'll replace the y in that equation for the negative 3x in the second equation. Thus we call it substitution. So negative 3x equals 3x plus 6. And now I'm going to solve for this. So I'll add, or I'll subtract 3x from each side. So that gives me negative 6x equals 6, or x equals negative 1. Now I found one variable, and I'd like to find the y value that goes along with that variable. And I'll take that negative 1 and I'll put it in the what I perceive to be the easier of the two equations to come to my answer, and that would be the second equation, because I've already got y on one side by itself. So y is equal to negative 3 multiplied by negative 1, or y is equal to positive 3. Now, there's this habit we can get into. We're saying, oh, I know the answer. The answer is x equals negative 1 and y equals 3, and we leave the answer like this. But that's a little bit sloppy. Remember that when we're solving a system of equations, we're talking about the point in space where they intersect. So let's write those as an ordered pair. This is a negative 1, positive 3, written as an ordered pair. So that's our solution. Now, you don't have somebody you can go to immediately and say, hey, is this right? And even if you did, nobody wants to sit and be your answer checker all day. That's not fun for anybody. You need to just be good at checking your answers yourself and making sure they work. Now, we already know that negative 1, 3 is a solution to the second equation, because we put the negative 1 in there to get the 3 out. What we don't know is if it also works in the top one. In other words, maybe we made a mistake. Let's check. So I'm going to do my check here. And I'm going to use the equation y equals 3x plus 6. And my y is a 3. My x is a negative 1. So 3 is equal to negative 3 plus 6. Matter of fact, that's a true statement. 3 does equal 3. So I know that negative 1, 3 is my solution because I got it by solving using substitution, and I checked my answer. Now let's go to another example, one where it's not set up where we can just automatically put one side of an equation into another variable. In this case, we're going to have to solve for a variable before we can do some substitution. So take a look at this and ask yourself, which variable would be the easiest to solve for? All right, I have my answer. Do you have yours? My answer would be this one right here. In x plus 2y equals -1, I'm going to solve for x. So x equals -1 minus 2y. And what I'll do is I'll take this -1 minus 2y, and I'm going to substitute that into the top equation for x. So 3 multiplied by -1 minus 2y plus 5y is equal to -1. Well, that looks messy and not much fun, but hey, we can work through this. We just have to distribute and simplify, meaning we're just going to combine all the like variables. So remember, step by step. If you don't show your steps, you're probably going to make a mistake somewhere and not know where you made a mistake. So this is -3 minus 6y plus 5y is equal to -1. Now I'll combine my like terms. So I have a -6y plus 5y gives me a -y. Now I also have a -3 here, and that equals a -1. So now I'm going to solve for this. Notice all I did was I combined these y terms. So I have -y is equal to -1 plus 3, which is 2. Which means that positive y is equal to -2. Boy, that leaves me a lot of room for errors. I hope I did it right, but we'll find out at the end if I did or not. Now, I need to find a nice place to put this y variable to find my x. And again, I kind of like using this first equation because x is already x is already a variable without a coefficient that's not 1, so that makes it easy. So I'll start there, and I'll have x plus 2y is equal to -1, and I'll substitute that -2 in there. So I have x plus 2 times -2 is equal to -1. So now I have x minus 4 equals -1, or x equals -1 plus 4 is 3. Now remember, we're going to write our answers as ordered pairs. So I'm going to claim that my final solution is the ordered pair 3, -2. I feel confident that I got that one right, but not so confident that I want to submit that to the world to see on a video without checking my work. So let me plug this into the equation that I didn't just use to check it. So in this case, I'm going to put a 3 in for the x. So here's a 3 times 3 plus 5 times -2. And I want to know if that does, in fact, equal -1. Well, let's see. So 3 times 3 is 9. 5 times -2 is -10. And if I add those together, sure enough, I get -1. So I checked. I feel confident now by saying that if I were to graph these, they would intersect at the point 3, -2. One more example, and then we're going to call it good. Now in this example, I wanted to use some coefficients that were not necessarily integers. So take a look at that top equation and tell me what you notice. Yeah, you're noticing that we have decimals. And if you're like most of the students I've worked with, you're going to look at that and say, oh, that looks terrible. I don't want to work with decimals or fractions. So let's talk strategies. Let's turn this into an equation where you don't have decimals there. So I'm going to change it. Negative 1.5x plus 0.5y is equal to 1. And I'm going to ask myself, what can I multiply both sides of this by so that this turns into, both of these numbers turn into integers? Well, I know that negative 1.5 is the same as 1.5, and 0.5 is the same as a half. So if I multiply these by 2, that should give me integers. I'll do the same thing on this side. So now I've got 2 times negative 1.5. That's going to be negative 3x. 2 times 0.5. That's going to be a 1y. I'll just put a y. I don't have to put the 1 in front. And that equals 2. So now the equations I've got 12x minus 4y equals negative 8. And these are my two equations that I'm going to use with substitution to solve. And once again, I'll ask myself the question, what would be the easiest number to solve for? Well, I think the x would be. And I think the y would be, sorry, I said x, I meant y. And that's because it's all by itself. It's got a coefficient of 1, and I can easily solve for that. So I'm going to take that equation, I'm going to rewrite it as a y equals 3x plus 2. And I'd like to put that into the bottom equation for the y that's attached to the negative 4. So here comes the substitution. 12x minus 4 multiplied by 3x plus 2 is equal to negative 8. And let's simplify. Oh, I forgot to put my x here. That would have caused me problems. So I have 12x minus 12x. Negative 4 times 2 is negative 8 equals negative 8. And 12x minus 12x is 0. And that leaves me with a negative 8 equals negative 8. And if you're scratching your head a little bit and saying, what just happened? What this is saying is, yep, that's a true statement. In other words, we have just discovered one of those situations where we have an infinite set of solutions. I submit to you that this is happening because these are in fact both the same line. Take a look at this set of equations again, and you're going to notice that if I multiply the top equation by 4, they're going to be precisely the same. So 4 times negative 3x is negative, I should say 4, I should have said negative 4. Multiply that by negative 4 on each side. And that's going to be a 12x plus or minus 4y equals negative 8. And that's exactly what the second equation was. So we've just shown you an example of how you might find out that you have infinite solutions even algebraically. So that was a video demonstrating how to use substitution to solve systems of equations. And if you're paying attention, you'll notice that we did a few things. Number one, we showed you how to check your answers. That's very important. And we also showed you how to take those coefficients and turn them into integers if you don't want to work with decimals or fractions. And that's all for this video. Good luck.